Welcome to Matter and Energy, Part 2, Learning with the Boys and Girls Club.
And now, ASAP Science presents the elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the signs, sodium for salty times,
Magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, then argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table, noble gases stable, halogens and alkyl react aggressively. Each period will see new outer shells while electrons are added, moving to the right. Iron is the 26th, then cobalt, nickel coins you get, copper, zinc, and gallium, germanium, and arsenic, selenium, and bromine film, while krypton helps light up your room, rubidium, and strontium, then yttrium, zirconium,
niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
then cadmium and indium,
tin cans,
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits, where lanthanides have just begun, lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62, samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium, hafnium, tantalum, tungsten, then we're on to rhenium, osmium, and iridium, platinum, gold to make you rich till you grow old, mercury to tell you when it's really cold, thallium, and lead, the bismuth for your tummy,
polonium,
astatine would not be yummy,
radar,
francium will last a little time,
radium,
then actinides at 89. This is the periodic table, noble gases stable, halogens and alkali react aggressively. Each period will see new outer shells while electrons are to the right. Actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, isonium, fermium, and olevium, nobelium, lawrencium, rutherfordium, wm, sprigium, borium, hesium, nemeterium, dubsidium, rhenium, copernicium, nihonium, flerovium, moscovium, livermorium, tennessine, and organesson, and then we're done.
So, what do we need today? You need your thinking cap. If you have a periodic table, bring it on with you. If not, that's fine. I will supply one for you here in the video. You really don't need it though. I really am asking that you bring your knowledge to the table here. Pencil and paper if you have one, but again, in most of my videos you need pencil and paper. Here, I'm just asking you to bring your knowledge. So come on in, let's take a test and see how you do. And then at the end, I'll send you in a certain direction. That's it. Let's have some fun learning. Our objectives today are to understand what properties describe matter, what matter is made of, and how can you classify different types of matter. All right, there are two types of changes that matter go through, physical and chemical. All right, what is physical change? Physical change equals a change that alters the form of appearance of a material but does not make the material into another substance. Examples: chopping wood, bending a copper wire, molding clay. Matter has three principal states: solid, liquid, and gas. A change in a state is an example of a physical change. Let's practice. Why is a change in state considered to be a physical change? Because a chemical change or reaction in a change is a matter that produces new substances with properties different from the original substance. Elements can combine to form a compound, or compounds may be broken down into elements. For examples, souring of milk and burning of wood. Energy is always involved when a chemical or physical change to matter occurs. Think of tearing a sheet of aluminum foil in half and then tearing the halves into quarters and then again and again. Could you keep tearing forever and producing smaller and smaller pieces? Or would you eventually reach the smallest possible piece? This is where the word atom comes from, which is the smallest part of an element. See the electron, proton, and neutron. In 1802, John Dalton, a British schoolteacher, proposed an atomic theory. His main conclusions were that atoms can't be broken into smaller pieces. In an element, all of the atoms are exactly alike. Atoms of different elements are different. Atoms of two or more elements can be combined to form compounds. Atoms of each compound have a unique mass, and the masses of the elements in a compound are always in constant ratio. Remember these things. Stop the video, read them again, because you're going to need to know them later. Today, scientists have identified some important exceptions to Dalton's statements, but his ideas still form the basis of our understanding of atoms. What were two of Dalton's ideas about atoms? Pause the video. Remember where I said to make sure you read because these are important? Nucleus. A nucleus is the tiny central core of the atom, which contains protons and neutrons. See the nucleus? Protons have a positive electric charge. Positive. Protons, positive. Neutrons have no charge. Neutrons, neutral. So protons is positive, neutrons is neutral. Although atoms are extremely small, they are made of even smaller parts: nucleus, protons, neutrons, and electrons. So, atoms have nucleus, neutron, proton, and electron. Electrons are very energetic particles that move in the space around the nucleus and carry a negative charge. Electrons are very energetic particles that move in the space around the nucleus and carry a negative charge. Okay, so all of the atoms of a particular element have the same number of protons because the number of protons is unique to each element. This number is called the element's atomic number. For example, the atoms that make up the elements carbon all have 6 protons, so that atomic number for carbon is 6. Part atom. The force that holds two atoms together is a chemical bond. Two or more atoms are bonded together to form a molecule. Some are made up of only one type of atom, but most are made up of 2 or more different types of atoms that are bonded together. Scientists can't study atoms by looking at them. They are too small to see. So how do they study them? They make inferences about them based on observations. They use models to make up and test their predictions. So how are atoms and molecules related? Molecules. Molecules are 2 or more atoms chemically combined. And compounds are 2 or more different elements chemically combined. Remember that from the last video? I thought you would. Gold and density. This is a cool part. During California gold rush, miners needed a way to remove gold from a mixture that also contained dirt and sand. Gold can be separated from other materials in a mixture because of its density. It has a higher density than most other materials, including fool's gold. Remember that. You're going to need to know that. Gold can be separated from other materials in a mixture because of its density. It has a higher density than most of the other materials, including fool's gold. They used the method of panning using a shallow pan and water. Because gold is more dense, it stays at the bottom of the pan when the less dense materials, the dirt, water, and sand, poured off. Pretty cool, huh? They use the method of panning using a shallow pan and water. Because gold is more dense, it stays in the bottom of the pan when the less dense materials, water, dirt, and sand, poured off. Yes, I said that twice because it's important. How could you tell the difference between the fool's gold and the real gold? Remember? All right, there's 4 ways to distinguish real gold from fool's gold other than just the panning and the density. Shine, hardness, and residue. When you're viewing fool's gold with the natural eye, it will glisten, not shine. You get a piece of copper and you try to scratch the copper with gold and residue. Gold will leave a pure yellow residue, while pyrite will leave a greenish powdery residue when rubbed against white porcelain. So that's other ways. Protons. Let's practice. Remember, pause the video. Protons have what kind of electric charge? And neutrons have what kind of charge? All right. Pause the video. If you said protons have a positive electric charge and neutrons have no charge because they are neutral, you are right. Great job. All right, let's practice this one. Who said atoms can't be broken into smaller pieces, and in any element, all of the atoms are exactly alike? Who said atoms of different elements are different? Who said atoms of 2 or more elements can combine to form compounds? Who said atoms of each compound have a unique mass? And who said the masses of elements in a compound are always in constant ratio? Who said this? If you said John Dalton said this, you are correct. Look for other lessons such as how heat changes the temperature of objects, cool periodic table, real life stuff, what Silly Putty was really for, and why it all really matters. See you soon.
And now, ASAP Science presents the elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the sign, sodium for salty times,
Magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, and argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table, noble gases stable, halogens and alkali react aggressively. Each period will see new outer shells while electrons are added, moving to the right. Iron is the 26th, then cobalt, nickel coins you get, copper, zinc, and gallium, germanium, and arsenic, selenium, and bromine film, while krypton helps light up your room, rubidium, and strontium, then yttrium, zirconium,
niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
then cadmium and indium,
tin cans,
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits, where lanthanides have just begun, lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62, samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium. Half Hafnium, tantalum, tungsten, then we're on to rhenium, osmium, and iridium, platinum, gold to make you rich till you grow old, mercury to tell you when it's really cold, thallium, and lead, the bismuth for your tummy, polonium, astatine would not be yummy, radon, francium will last a little time, radium, then actinize at 89. This is the periodic table, noble gases stable, halogens and alkali react aggressively. Each period will see new outer shells will electrons are to the right. Actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, isonium, fermium, indolium, nobelium, lawrencium, rutherfordium, wm, sprigium, borium, hesium, meitnerium, dubsinium, rucenium, copernicium, nihonium, flerovium, moscovium, livermorium, tennessine, and organesson, and then